I am Cedar Malazzo. I'm the Senior Program Director of Smart Networks at NETGEAR. And Smart Networks is basically our development platform for all of our devices that we're going to be supporting. I'll tell you a little bit about kind of the background of what is a network app, what is a smart network. We'll talk a little bit about some of our partner experiences, and we'll also go through, or Dennis Aldover, our engineering manager, will go through some of the architecture of our development kit and actually step through some coding examples. And then lastly, we'll talk a little bit about how to monetize a network app. Just to get started, a little bit of background on NETGEAR itself. We are the number one global brand and distributor for network devices. That includes routers, DSL gateways, network attached storage, devices like that. To date, we have approximately 80 or 85 million devices in the field as an install base at the moment. These are probably over the last 3-4 years. And we obviously ship to worldwide. Most of our market share, of course, is in North America, Europe, and Asia. So I want to talk today a little bit about what a network application is and what a mobile app, and how does it differ from a mobile application. First of all, you guys are all familiar with mobile applications, and some of the drawbacks you have here are they are peripheral to the network. They can be moved out of the home or out of the business, and they don't have direct access to other devices. In other words, these are actually mobile devices, right? So if you have an application that always needs to be in contact with other things inside the home, for example, these types of applications can't really run on a mobile device. Whereas with a network application on, say, a router, you actually have the ability to actually sit there on a device that's always turned on, always connected to the network, and able to control and monitor the traffic flowing through that network. In addition, you have the ability to look at the data in the network and potentially manage the data and control the data and where that data goes. So these are some of the key differences between mobile devices and devices that NETGEAR ships, such as routers and DSL gateways and network attached storage devices. So what we decided we need to do is open up these platforms to third-party developers and let them develop applications that require these types of functionality, this always on, always in the home type of functionality. So we built out a development platform on these devices, and I think probably some of you have come by our booth earlier in the week and got a little bit of a feel for that. But today I'd like to go through some of the detail architecture on that as well. So what can you do as a network application? So we have these differences between mobile and network applications. What can you actually do with that? That's one of the biggest questions we've gotten on the show floor in the past couple of days is what can you actually do? Well, there's actually quite a lot. First of all, there's some of the obvious things like network security. Use cases like monitoring your internet usage and notifying you if something improper is happening. There's connected home type of applications as well. If you go upstairs to some of the demos they have upstairs on the embedded suite, they're talking a little bit about managing your energy and home control and things like that. These are types of applications that really need to be inside the home, running at all times on some sort of embedded platform. And with our platform, this enables this type of application to be built. So, for example, you can monitor your grandmother or a sick elder inside their home, so they can stay in their home instead of going to a nursing home. You can turn your router into a voice PBX system and put that into a small business. And then on the media side, there's a lot of potential applications as well. You can actually control and move your data around in quite a lot of varieties. And we'll actually I'll actually have a video later in the presentation of one of our partners who's built an application based on just this idea. We also have the ability to do a lot of social network media sharing and things like that, which are kind of some really interesting ideas around how you can actually keep control over your data as opposed to posting it on a site like Facebook, for example, where you potentially lose some control over it. Again, these are all dependent on three main features. First of all, that device that they're running on has to always be on and always in the same location. You have to have reliable access to it from the internet or from local, and you have to be able to control and store data, potentially large amounts of data. And the platform that we're talking about today actually provides all of these. So on a router, on a DSL gateway, or on a NAS, again, I'll go through those devices. You'll hear those device names a lot of times today. But they are the types of devices that are sitting in the home or sitting in the small business that are always providing these kind of capabilities. So if you look at what we've actually built on top of these devices, we have three main pieces. One is what we call our control point, and this is the software that's running inside the device, inside the home or business. And this is a Java-based platform running an OSGI Felix stack on top of it that enables third-party developers to write applications and deploy them onto that device. So it opens up these devices that previously had been kind of sealed devices with a firmware that doesn't change on them. Now they're opened up so that developers can write applications, push those applications onto the devices, and kind of monetize their efforts. Gets you. So the other piece that's really interesting here is the user interface. Now with our technology, we actually have an XML API, so you can use really any technology you want to on the user interface side. So you can use an iPhone application, or you can use a browser-based application, even PC if you want to. And then the third piece that ties it all together is our cloud services. So this includes our marketplace itself. So once you create an app, you can actually put it in the marketplace and get access to all of those users out there. You have the developer portal where you can actually create an account, get our SDK, interact with other developers, talk to people within NETGEAR on our blogs and forums and so on. And then lastly, we have the customer portal. And the customer portal is really important because it actually provides access to all these applications once they're installed. So if you want to, for example, as an end user, you want to see your network or you want to see your applications on your network, this is where you would go to actually interact with those applications. And this provides that ability to launch your third-party applications or your NETGEAR applications. So these three pieces comprise the overall smart network ecosystem and the basis for our developer platform. So when all these come together, the basic idea is no matter where you are, anywhere in the world, you have access to your devices. And that it doesn't matter if your devices are in your home or in your business. You know, if you have a distributed business model, for example, where you have, let's say, convenience stores, for example. Maybe you have a headquarters that has some monitoring systems on it. You have a remote location where you actually can turn the lights on, security on and off, and things like that. And then you have an offsite backup in this example. This platform with the NETGEAR platform and an application built to support these different use cases can actually tie all these together. One simple interface that enables you to get access to all of these different homes or business locations and access all the different devices with them, access the data within them, and control basically all these things in one place. I know I'm going kind of quick, so if anybody has questions, feel free to raise your hand at any time. I know we'll go into a little bit more technical detail later, but even if we're going through this, feel free to interrupt me with questions. So next I'd like to actually talk about one of our partner experiences. Qualcomm has created an application. Actually, I'll let him talk about it. I have my mouse here.
We've created an application called the Skifta Engine, which turns a NETGEAR ReadyNAS device or a smart router into the locus of control for media management and playback within the connected home. So it really makes it easy for consumers to be able to take all their music, photos, and videos and essentially liberate them from the storage device and be able to stream them in full quality on televisions and stereos. One of the key things around development of the Skifta engine was that we chose the Java platform as the best approach to deliver this software because of its extensibility and the opportunities that it afforded device manufacturers to be able to more easily distribute and update the software. And the NETGEAR Smart Network, with its Java and OSGI backend, really fit nicely with our product strategy. A few of the big things that we looked at with the smart network and assessing the viability and how this would match our current software strategy was how extensible the platform was, both in terms of ease of use as well as the feature set. And we found everything from the early stage development tools up to e-commerce and having the ability to create flexible pricing and distribution models, and then the follow-on analytics to really understand how well sales and performance of the application actually went. We found that entire suite as an end-to-end solution to be top-notch. The NETGEAR platform actually gives us an opportunity to reach a category of consumers that traditionally have not been able to be reached via other means. And we're able to tailor our offering specific to those customers. So you find yourself in a position as a developer to be able to minimize your customer acquisition cost, really dial into what that consumer is looking for. And as a network, the smart network is one that we see is at the forefront of what other companies may be in this space or may be looking at, but NETGEAR is actually pushing the way towards this way of extending the life and value of connected hardware.
Okay. So again, these three pieces built together, along with the third-party applications, enable you to reach quite a wide, a large install base of customers, in the 80 to 100 million user range. So these three pieces build up our smart network. And to go into more detail, I actually have Dennis Aldover, who is our engineering manager. He's going to talk a little bit about the architecture and actually go through a coding example. So Dennis.
Good morning, everyone. Feel free to interrupt me if you have any questions. If I go too fast, raise your hand, slow me down. As Cedar pointed out, we have a complete solution which allows you to create your application using your favorite front-end technology to create your user interface applications, and we also provide libraries to develop your Java-based or native code application that runs on the control point. And like Cedar said, there are 3 main components for a smart network ecosystem. And in the code review that I'll be doing in a bit, I'll show you the basics for creating these components. On the control point, what we have there is an OSGI-based bundles service that are running. It gets downloaded from the cloud by the user on the device. And on the remote side, the user interface, what I'll be showing you is a GWT-based UI application. And we use XML-based messaging protocol that goes through the cloud to the device, and I'll be going to that into details as well. Next one. All right, so here I'd like to start first showing you about the control point architecture. Basically, what we did is take the Linux OS and we put a Java VM, and on top of that we put in an OSGI framework. We use Apache Felix 4.02 distribution, and then we added our libraries, our APIs, to make it easier for developers, provide helper classes to get access to the cloud. And if you go to our marketplace right now, we have an application guest network that uses such APIs, and also we have a Wi-Fi settings application in there. And we also support your application if you use third-party libraries. You can bundle up in the OSGI application, and you can call your third-party drivers through JSNI. Also, what we have on the cloud now is our dashboard. It's our user-facing web application. In there, we provide helper classes for your UI applications to communicate to the cloud. We have you can create widget type application, those little small gadgets, and a full screen application. Communicate through our JSNI interface, and I'll be showing you that in a bit. And you use that to basically do some async communication between your UI component and your OSGI-based application that's running on the device. And also on the portal for if you have like clients that don't want to be hosted by our user-facing dashboard, we have also remote APIs to do this kind of asynchronous communication. All right, but how does the UI component talk to your OSGI component? And it all happens because of FCML. This is the XML-based message protocol that we use in our system to let you identify where the message came from and where you want it to go. It's basically a message routing protocol. And over here, I don't have a pointer, but as you can see, it's an analogy here is like a snail mail, right? There's an envelope, and in an envelope is the sender and a destination where it's going to. And inside the envelope is your message. So basically, as you see there, the light 1 is your object that you want to use, and set is the method that you want to do. And basically, the state and brightness are attributes that you want to happen for that specific object. And in this case, you want to turn it on and set the brightness to 100%. Here's another example. And this is more about an interaction between a UI application and the control point itself. Basically, your UI application is given the client ID by our portal, UI23, this one. And you're sending this message to the light control application that is on the control point, which is ID'd by the system as CP1458. And again, we're using the same FCML message on the other side, on the previous slide, and we're setting the brightness to 100% and turning it on. On the light control application that's on the control point side, when it receives the message, it performs the function of turning the light on and setting the brightness to 100%. It then confirms that it received that message by responding back with its object, the object that acted on that message, and with a .is method, and it's basically broadcasting. It's like the asynchronous messaging that I talked about. It tells everybody within the system, within that account, that hey, I'm here, and somebody changed my settings to 100%, and I'm now on. So if you have other clients within the ecosystem, they'll be able to determine this change and notified of this change. Any questions? No. Okay. All right. So is it in here? Okay. So I'm just going to go briefly and do a code review on how do you do an OSGI based application and how you would do UI. First thing is, this code is available in our developer portal, so I'm going to briefly go through and review some of the key components. The first thing that I'd like to show you is the Hello World service. So this is the key thing for being able to communicate to our portal. Basically, you develop your Java application and extend this plugin core client. And then you give your application a name. Service. This basically this service name is what identifies your name. In this case, it's called NETGEAR Dev Hello World. And basically, when you override the run, you just call the start receiving. And once your bundle gets started by the OSGI framework, it will start receiving messages from the system. And then you implement this FCML executor. You extend it from this base class. And over here, basically you invoke this process method on the base class. And that, by calling that, all your override methods for handling the different messages, like handle the light is method that we saw earlier, and also the set. Right? By calling that process method, the system calls your handle set override method here. Basically, what's doing here, it's going through this fluid object node, which is basically a parsed XML object, walks through it, identifies if it's something that you're interested in, if this is your object, and it basically looks at the attribute, and then you can act on the specific changes that you want for your object. Any questions? Okay, so that's basically the two critical parts of being able to communicate using FCML in our system, right? You create a plugin core client, and then you implement this FCML executor, and then you override all this method in the FCML executor so you can act on the messages that you'll send or what the system will send you. And then the other piece is how do you create the UI component.
So the return is a null value. It's only a state change that you accomplish in the methods?
Yeah, but there's this asynchronous communication that we're doing. So basically in this apply, select, and respond, you're basically generating the message, the XML payload, and sending it back to the system.
Oh, so you send the message back before the method returns.
Yes.
So this might go into that.
Oh yeah, let me go in here.
So is this a blocking method?
This one? Yes.
Blocking, okay.
The controller doesn't work here. I can't go in there. Yeah. Yeah.
Can you repeat his question? What was he asking?
Oh.
He was asking if it was blocking. In other words, if that call, doesn't return, you're not going to return until after that call gets back to you.
Is the GRE the SE edition, or is it a lighter weight?
Yeah, we use OpenGDE SE, but we stripped off some of the UI classes to make it a little smaller.
What is it? Is it running 6?
1.6? Yes. All right. So for the UI side now, how would you do a simple UI application that loads in our dashboard? Here we have a gadget application using GWT. We provided some helper classes to make it easier for developers. Here, what we have here is a components jar, basically some common UI helper classes, to get the status of the device. How do you get the status of a device? Basically, let me go through here. So here, what we have here is a set of classes that we have implemented so you can communicate to the basic services that we have on the control point. If you're developing an application for the router, let's say, there's this net router service that's running on the control point, you'll be able to access these objects, like what's the wireless settings, what ports are blocked or accessible, and you can manipulate those objects for that service. And what I want to show you here is what you need to do on the UI to make this all work. After creating a GWT project, you basically import all those classes into your library, and you implement on the onload. You implement this FCML init call. Right. Basically, this is the first step that you need to do before you can communicate on our dashboard. It's sort of like when you go to the developer website and apply for to submit an application, you need to get an application ID, and in here you authorize your application by calling this FCML init. You're basically telling the framework, hey, I'm here, I'm a UI application, here's my application ID, and I want to start communicating. Right. And this tells our system what methods you can send and what objects you can access. And here this goes through the JSNI that was, sorry. Yes, the JavaScript native interface here in our library, the NETGEAR dev. We have a post message.js. Let's wait for it to load. So basically, we're just using post message between your application and our dashboard to communicate. So when you send a message, it goes through post message. When you receive, it calls your on listeners through this JSNI. All right, so let's take a look at an example. This one, service controller. So that service that we saw earlier. Basically, we had a hello world application service that's running on the control point, and we had a hello world object, right? So what I'm doing here is I'm creating a query using our client query helper class, and basically you're sending a message to that NETGEAR hello world service that's on the device, sending it to the portal, And before you're doing that, you set up your listener. And when you call execute, basically it sends it through the JSON line, through our dashboard, which sends it to the portal. And the portal routes it to the control point using the control point ID, which is you specify here. Right? And then when the control point responds back to the UI, the dashboard then routes it to your application and calls your listener, and you get it on this on result. Then it's your duty to parse through the objects. We basically parse the XML message for you, put it in an array of fluid objects, and you go through it one by one and see if this object that you're interested in, and then you act on the methods or state changes or attribute changes that you get from the control point service. So you take this UI application and the control point service, you package it all up in a zip file. We have it's available. How you do that is available on the developer. I don't have, on the developer website, and basically submit it through our submission process in there, and that's about it. Any questions? Sure.
I'm not familiar with the hardware device. Is this a shipping product, or is this just in development?
Yeah, we have one router, the 3500 LV2, and two NASs, the Duo V2 and NV plus V2.
So these are consumer products they can buy off the shelf, or is this something through a distribution partner?
Yeah.
Or channel?
It's retail. Yeah.
It's off the shelf.
What's the price point?
The 3500 is this on? Can you guys hear me? So the 3500 is, I think it's around $60 to $70. So it's a mid-range router. The NAS devices, I think, are between $200 and $400 depending on the configuration. So how much hardware or how much hard drive space you have on them.
So this serves as the users, or as the residential gateway for internet services and routing for their network, and then on top of that, there's these added services. You're exposing an OSGI framework for third-party developers to create applications into.
Exactly. Yeah. Now the router side of things provides that gateway still. The NAS side is really it's a device that's strictly designed to be a network attached storage device, and we're opening that up for this type of applications as well.
So this could be exposed to the outside network too?
Yes.
Yes?
So, out of curiosity, what about devices like cameras, and you mentioned there's home control devices. What options do developers have to gain access to that kind of information? Is it parsing packets? Is there control messaging, XML messages being pushed back and forth between whether it's NETGEAR specific products or third-party products?
So Dennis mentioned the net router client earlier in his example, and that actually provides APIs to talk to the router itself. So you can get information like what devices are connected and get their IP addresses and things like that. You also have the ability to listen to UPnP, for example. So you can actually find UPnP devices like cameras and interact with them that way. So depending on what level of interaction you need, you can basically look at either the connected device or actually go through UPnP or DLNA or some other protocol to actually find the devices within the system. What's interesting though is with this FCML communication, we actually enable you to write an application that, for example, talks with UPnP and exposes via FCML to other applications those devices. So you could actually write an application that talks with cameras, for example, and exposes the camera functionality to other applications if you'd like to. So instead of just having a camera monitoring application, you can have an application that supports camera monitoring, but also maybe something integrated with motion sensoring to turn your lights on or something along those lines.
Yes.
We saw some example during the keynote about home devices, temperature sensors and stuff like that. Are you also covering any of that, or probably more trivial, the bandwidth of some of the connections themselves?
So we've actually put together prototypes of Z-Wave and Zigbee type of applications. So we definitely can do that using this platform. We're not providing an application that controls lights or anything like that, but we definitely have the platform that enables someone to create an application that does that.
Yeah.
The protocol itself, I haven't really heard of this, but there are some other mostly IBM-driven initiatives like MQTT in the Eclipse M2M working group. Unfortunately, all other Eclipse people besides me seem to be in the main keynote over there. On the big stage, not in here.
So there's also
Is it
efforts.
somewhat similar?
Yes, it is similar. There's also efforts under, so, for example, the OSGI Alliance has efforts under, to standardize some of these device interaction protocols.
Are you aware of or involved?
We are monitoring those.
Industry working group at Eclipse?
We are monitoring that. We're not actually involved in it, but we are monitoring that. I get emails on everything that comes across.
Mailing list or something.
Yeah, exactly. So we're keeping track of it, and we're making sure that our stuff is compatible, but we're not actively going out there and making contributions to those.
Yes.
What kind of resource constraints is the developer typically under in the devices that you're putting out?
Yeah, you have to be very careful because, especially on the router side, right? Right now, it's fairly limited. The memory, I think what we have now, it's about 64 megabytes to work with. Most OGI applications that we've seen are make use of small memory. So those are pretty efficient. But on the ReadyNAS side, there's plenty on that.
Terabytes of storage.
The storage and for memory, there's a lot more than the control point. On the router.
So when you're talking about 64 megabytes, I'm assuming that's the RAM side. Right?
Yes, the RAM side, yes.
And then, out of curiosity, how constrained is storage then? So, classes and all, or any other supporting?
Yeah, most of the routers have USB ports, so you can, and people attach their USB sticks or USB drives, and if you see it available, your application can get access to that, and you have more space.
But
To store the
answer,
application, how much
Oh, for storing an application, we have right now on the
all the devices
Settings.
that are supporting this platform have at least 128 megabytes of flash. Now, of course, some of that is taken up by the firmware and the platform as well.
Yeah.
So typically, we allocate maybe 64 megabytes for applications.
the NAND space.
So they're not designed to be huge applications. We want to keep them as small as we possibly can, make sure they're efficient. And in addition, we want to be able to have more than one application on the device, right? So we definitely want to keep those as small as we can. Okay. Any other questions?
Sure.
One last question. So to sign up as a developer, is there there's a developer portal or something you can sign up with? Is there an annual fee, subscription? What's
Yes.
Yes.
required to-
Yeah, so we'll go through a little bit of that in a little bit. We have some more slides to go through. But yes, it's very similar to like the Apple development agreement, and basically it's a $99 subscription once a year, 70-30 split between NETGEAR and the application developer and so on.
You're allowed to develop open source under your...
Yes.
Yes.
Because Apple handles this a little bit different mostly.
There are definitely some differences between what they do and we do, of course.
All right, thank you.
All right, so Dennis kind of went through the architecture and examples, but from a business perspective, I'd like to hear a little bit more from another one of our partners, a company called SimForm, who's built an application based on the ReadyNAS devices, and I'll let you hear directly from them.
SimForm has a cloud data backup service, and we've created a way to easily download our application from the smart network so that NETGEAR customers can back up all of the data in their NAS devices to the cloud for that second tier backup and data protection. We are actually a distributed or crowdsourced solution. So everyone that uses the application is contributing to the service or contributing to the network. So what makes it great about working with NETGEAR customers is they really understand this very quickly, and they understand that they can contribute to the network some excess local drive space, and in exchange they get that layer of data protection and cloud backup within the network. What was great about working with NETGEAR is the market reach that we will also get. Immediately, we have access to tens of thousands, hundreds of thousands of NETGEAR customers. This is easy for really any developer or any type of application. We're a SaaS-based application or cloud-based application, and really all we needed to do was to create that Java-based package for our application to make it relevant and easily downloaded from the marketplace. The cost of doing that was low for us, but the time to market was very quick. The SimForm application is available now on the Genie Plus marketplace for all Ready NAS and NAS products, so we're very excited to launch this with NETGEAR.
So a little bit more about her application. So the SimForm application is a Java package that's downloaded to the Ready NAS, but it actually communicates with their back-end service as well, and that's kind of controlled within their application space. So once that application is on the device, NETGEAR steps out of the equation. We're not processing the data, we're not sending it through our servers or anything. It's handled exclusively by that application provider. So we enable you to basically take control of that application and basically implement however you need to implement within your space. So to answer your question earlier about how do you become a developer, basically you got to go to our developer website and create an account there. Takes you 5 minutes or so to do that, and start downloading the SDK and looking through the tutorials and so on. Developing your application is fairly simple, like Dennis described. Basically, you write the user interface in whatever technology you want. You can use our libraries to build it, or you can use an iPhone interface or iPad interface or even a native PC-based interface if you want to. And then you package all these things together and you put them into our developer website. We have an upload functionality there. You upload the app. We go through some validation to make sure it doesn't do nasty things to our devices, and we approve it. And then you can basically go ahead and set your price and start selling it. As far as submitting the application, every application has a unique identifier that differentiates it from other applications. So you have to request an application ID from NETGEAR before you really get started. Now you can write your own code and all that with a temporary ID and test it, but before you submit anything, you have to have a NETGEAR issued ID, and that basically enables us to provide services to your application. So when a user sees your application, they actually get notified of what services you are requesting. And based on the security level, they can actually choose to install or not install that. So if, for example, you want to get access to all their network data, everything that flows through the router, they have to be aware of that and approve it. And so we need that application ID to correspond to that. So once you have that application ID, you can actually go ahead and create your OSGI service component and your user interface and so on. And like I said earlier, submit the app into our developer website. Once it's approved, you set your price. You decide where you want to sell it. If you want to sell it worldwide, that's simple, easy to do. If you want to sell it in select countries, that's also easy to do. Right now, at the moment, we are selling strictly in the U.S. only. We have plans to launch in Europe and Asia by the end of this year as well. So kind of in summary, this basically really is a true end-to-end system. It provides all the development environment. It provides the hardware devices to run on. It provides access to the customers through our marketplace. It provides an interface for those customers to actually see your applications and start running them through our dashboard. And you know, it's based on revenue sharing. So we are not successful on this unless you guys are successful as developers as well. So we're really trying to do our best to make sure that we help these third parties such as yourselves create these applications and make them successful. And we don't see this marketplace as being, you know, the order of magnitude of say Android or iTunes. We're not looking at 500,000 applications. We would be happy if we had 500 applications. So your application is not going to be lost in this huge mass of other applications that people have to search through and find and things like that. It's really dedicated to more of a select valuable set of applications that actually provide real value to the end users and enhance their life.
How many devices are actually out there that this can be deployed to?
At the moment, so we just launched this 3 weeks ago. So at the moment we have, I believe there's about 300,000 Ready NAS devices out there. And on the router side, I believe it's about 150,000. We're launching 2 new routers before the end of this month, and that'll expand the reach by about double. And then we're looking at doing that basically every couple of months and expanding on to more of our products. So initially it's fairly limited, but by the end of the year we're looking at probably close to 500,000. By the end of next year it should be about 20 million.
Internet of Things you may call 500,000 limited.
Yes, we do see it as limited, but remember these are end users, right? These are people, right? This is not devices necessarily, that you don't think of it as devices, you think of this as people who are actually using the devices, right?
Just users of devices, it's not individual devices.
In many cases they correspond one-to-one, but you're getting right directly in front of those end users, right? Right here?
So, can you update like a Ready NES 4000 series? That's older, can you have this capability?
So the question is on backward compatibility of ReadyNAS devices. And the 2 devices we have for ReadyNAS that are supported right now are the ReadyNAS Duo and the ReadyNAS NV Plus. Those are the only 2 that are backward compatible right now. You can get a firmware upgrade for those 2. Anything older than that is not supported at this time. Again, we're going through our product line and adding this to additional devices as we go. So it's potential other devices that are already out there may be upgraded to that as well.
For the router devices, it's one of the permissions to have, say, arbitrary access to the net that they didn't necessarily, that the user didn't initiate the app, can initiate like a HTTP request and such.
The question is whether applications can have basically open access to the internet. And the answer is yes. The user has to be notified when they download the application that the app does it, yes. So they have to agree to that initially when they buy it. But beyond that, we don't really control that. Now, when we do our approval cycle, we will monitor that and make sure you're not taking something that you shouldn't be, that restricts our permission, that restricts the security concerns around that. But yes, you do have the ability to open up an internet connection. In fact, the example we had earlier with SimForm, that's exactly what they're doing. They actually have a connection back to their server side. Doesn't go through any NETGEAR site. It goes directly back to their server and transmits data back and forth. Yeah.
Which of the Java editions is running there? Is it like the former J2ME embedded class, or the embedded that is now being based on SE?
This is actually a real SE version. This is not even the embedded version. So we're actually running at the moment OpenJDK SE 6 version 6. Question here?
Oh, in the marketplace, is it just one-time purchase apps, or does the marketplace also facilitate the subscription model?
Question is whether we only support one-time fees or subscriptions, and the answer is we support both. So you can create an application that does a monthly recurring fee or an annual recurring fee. You can set up to do it every 2 months if you want to. So it's fairly flexible in that respect.
Another question.
Sure.
I'm curious on your router side, how is NETGEAR fully embracing OSGI in the sense that once you have firmware on the device, it enables the OSGI framework? Is your router software functionality written in OSGI? I mean, if you made a change to the GUI or something, would you redeploy that as a new OSGI bundle, or is that still a firmware?
At this point, the router user interface, sorry, let me repeat the question. The question is how deeply is OSGI embedded in the router firmware itself? Are we using it internally? The answer is at this point in time, it's not being used by our internal user interface. The plan is to move it in that direction. We have to do this in steps, but the plan is to move all the functionality that's not, embedded in the router itself, the basic routing functionality. Anything additional to that will be moved towards these applications. And they may be default applications that are always installed, but they'll still be OSGI applications. Now, to clarify a little bit more, the Java and OSGI stack is embedded in the firmware. So when you get it from the factory, it will have that on there. Question?
And do you have any thoughts about Jigsaw and Java SE modularity and how that might influence what you guys do down the road?
The question is on Jigsaw and Java SE modularity. At this point, we haven't really been considering that. down the road, that's probably going to be a pretty strong consideration, but at this point, we haven't really evaluated it.
Another thing, how about other JVM languages? How difficult would that be in this environment, especially being on device?
So other JVM languages and how we could put that into the device itself. Now, that is possible. You're talking about something like Ruby or JRuby, exactly. That would definitely be possible, as long as you can package that within your application. Exactly. Then that can be done. We don't have restrictions on what you can compile into your class files. In fact, as Dennis mentioned, you actually have the ability to run native code as well on this device at the Linux level. So you can actually package C and C++ code in there and have a JNI interface to communicate with that C code as well. So the question is what some of our competition has announced. You're talking about the app-enabled routers and the cloud stuff from D-Link and Cisco. The answer is they have basically created an API in the cloud that enables mobile applications, iPhone, iPad, Android, and so on, to communicate with the device to configure it. So basically their applications are basically configuration applications or whatever's built into their firmware. They don't actually allow you to download applications onto the router itself. There's a big difference. So they basically put applications in the Apple Store and the Android Store. We actually have a marketplace that has applications that get downloaded to the devices. It's a key difference there. Any other questions? Okay, thanks. So these are the two important URLs. The first one is the marketplace itself, so you can look at that. Unless you have a device, you can't actually download applications or anything like that, but you can certainly see what the context looks like, see what the applications look like, see what's out there. And then the developer website where you can actually go and sign up and get the SDK and get started actually developing the applications. So any other questions? Sure.
Can you get access to the SDK documentation without having to have a subscription?
Yes. So the question is whether you can get access to the SDK and everything without paying the subscription. The answer is yes, you can. So you just go in there. You still have to create the account. You can start using the SDK and everything. You can't submit an application until you've subscribed, but you can certainly develop your application. So it's okay. Go ahead.
I was going to say you can still run it on your local dev machine, no problem, without having to have it approved with the market yet.
The question is whether you can run it on your local machine. Yes, absolutely. The SDK basically tutorials step you through exactly how to create your application and install it on your local router, so you can actually do testing and things like that. Absolutely, without having to submit it.
Yeah, I'd like to add on top of that is we also have, since we're using the Felix distribution, you can just run it on your Linux box or just run it off Java. As long as you don't do hardware, low-level stuff on the hardware, you can test your application.
Is this mic on? Can you guys hear him in the back? Okay.
Yes. Hello. Yeah, I was. I just wanted to add that in the developer website, you can also find out how you can use our simulator. Basically, we're just running the Felix distribution that we have on the device and test your application on your desktop, your laptop.
So is it like a VM or you just run it on any Linux?
Yeah, so you install Java and then you run Felix, and basically in our bundle, all our core bundles will be available for download as well, and you trigger the script to start the application, and basically it's functioning as if you're on the device, except you don't have access to the hardware functionalities.
So the base platform itself is actually an OSGI application as well. So as long as you have a Java VM and an OSGI there, you could actually install all of our, what we call the control point, onto that OSGI platform and basically run that as a simulated environment on your PC or whatever Linux device you have. Did you have another question?
Actually,
that was it. Okay. Over here then.
The SDK, does it also have IDE support? I saw on the slides you used Eclipse. Is that the IDE or is it independent of the IDE?
It's fairly independent of the IDE. We have a bunch of libraries and things like that. All the tutorials we have out there use Eclipse as an example. There's nothing to say you can't use NetBeans or some other IDE if you'd like to, but we don't have environments set up and things like that in the tutorials.
Why do you prefer Equinox? Was it because it's said to be closer to the OSGI standard, or what was the reason?
Yeah, basically that is the main reason. It's more standardized. It's also a little bit smaller in some respects for the pieces that we're using. So it's a little simpler to actually get everything up and running, and it's a little more compact. Now, to be clear, we're only using standard OSGI. So if you make use of any OSGI services within your applications, if you go outside of those standards, you need to make sure that your application includes them in your packaging. Any other questions? All right, well, thank you all for coming. Steve Lipinski, who's our marketing manager, is also here. He's actually handing out USB sticks with the presentation on it, so feel free to look through those as well. And thank you all for coming.